Okay, let's talk about the kinematics. So in this problem, we're given this kind of setup. There's a projectile launcher that launches the ball, and the setup is here. The ball is released with the initial velocity 3.2 meter per second, and the direction of release is purely horizontal. The question is, find the horizontal distance traveled by the ball. So what's given here is we have this horizontal velocity. When the ball is released, it will release like this. And because of the gravity, it tends to go down. So it forms the motion is like a curve. So for this one, we only know this. So we need more types of quantities to calculate this horizontal distance. So let's consider it in the other one direction. So in one direction, when the ball is released, it has the initial velocity 0 because the release is purely horizontal. And the acceleration, which is only due to gravity, so it's 9.81 meter per second square. And we have the height of the table here, which is 1 meter. So let's use this. So from the y direction, we can get the time it takes the ball to reach the ground. So if we know the time, then with this horizontal velocity, we can calculate the horizontal distance traveled. Because in the y direction, there is an acceleration. However, in the x direction, we're ignoring a resistance in this kind of setup. So in horizontal direction, the velocity is going to be the same. So let's go back to the y direction. Let's use this one, s equal to, ut plus half at squared. So u is going to be 0. So we just have half at squared. So here t will be equal to 2s over a and the square root here. Let's substitute the numbers. So it's approximately around 0.452. And by using this quantity, the time, we can calculate the horizontal distance traveled. So in the x direction, there's no other force acting on the ball, so the acceleration is 0. And we have the initial velocity, which is 3.2 meter per second. Also, in the horizontal direction, the initial and the velocity is remaining the same, so we can just say this is the final velocity or whatever, since the velocity is not changing at all. Okay, so we can use this same equation here. S equal to ut plus half at squared. However, here a is 0, so all this part go to 0, so we're left with s equal to ut. For the accuracy, I'll just use this rather than the decimal. So in the x direction, u is going to be 3.2 and t is going to be square root of 2 over 9.81. And when you calculate that, you'll get around 1.44 meter. Okay, we're done. Let's move to another. So for the next part, determine the effects of increasing the height of the table on the horizontal distance traveled by the ball. So in this setup, let's go back to the picture. we're going to increase the height of the table here. So how is this going to affect the distance traveled by the ball? So we can consider it from our calculation here. If we increase the height of the table, then you can say the time it takes for the ball to reach the ground, it will also increase. Let's write the equation. Instead of s, let's just write the height of the table. So it's the same from before. T is equal to square root of 2h over a. And in the previous question, we used this to calculate the horizontal distance. So in horizontal direction, there's no acceleration. So we just have s is equal to u times the square root of 2h over a. Okay, so if we increase the height, that means the horizontal distance traveled by the ball, it will also increase because here s is proportional to the square root of h. It's directly proportional to the square root of h, so increasing the height of the table causes an increase in horizontal distance traveled by the ball. Alright, for the last part, the effects of decreasing the initial velocity on the angle the ball hit the ground. The angle is with the horizontal surface. So here, when the ball hit the ground, you see the angle with the horizontal surface is something here. So how does decreasing the initial velocity affect this angle? There are two ways to consider it. Like, okay, so if we decrease the initial velocity, which is purely horizontal, that means this ball, uh, and the height of the table, it remained the same. So in the same amount of time, the distance traveled by the ball, it will decrease with decreasing initial velocity. So it would just go something like this, or maybe this. So you can see the angle, it gets bigger as the initial velocity is decreased. We can show it with a sketch, or there's another way. When the ball hit the ground, the final velocity, it will be something like this. So it has two components, like the horizontal component and the vertical components. So decreasing the initial velocity, that means decreasing the horizontal velocity. So how does horizontal velocity have the effect on this angle? We can use trigonometry to find out about this. So here we have the vertical and the horizontal. We can just use the tangent. So tangent means opposite over adjacent. That means Vy over Vx. The vertical divided by the horizontal. So as the horizontal velocity decreases, that means tangent also decreases. So that means theta, tangent theta, it will be increasing. That means theta increases. Yep, that's all. Thanks for watching.